Hello. This video is going to explain in some detail how to figure out how to do steps 5 and 7 on these instructions for graphing and finding the slope of a line. Finding the smaller scale for the graph paper that we use that has 5 small boxes, both vertically and horizontally. Inside of the bigger scale that we're going to use sometimes is a little challenging. So hopefully by the time we're done with this video, you'll have a pretty good understanding of how that works. So what I have is another piece of paper that has a few of these kind of larger boxes in. Each of these larger boxes represents one of the large boxes on our graph paper. And just like on our graph paper, each of these large boxes has 5 smaller boxes, both vertically and horizontally. And we'll use these 3 as examples of how to find the scale of these small boxes that then we can use on our graph paper. Okay, so this is the process we're going to use. Earlier in the instructions, you did find out how to actually find out the scale for the large boxes. That will be in the video that is labeled creating a graph. So if you find the video creating a graph and do that one first, you will know how to find the scale for the large boxes, both vertically and horizontally. And let's say we've already done that, and we've discovered that vertically we need to count by 3s. So this number might be 12, this number might be 15 if we're counting by 3s vertically, and horizontally, let's say we found out that we're counting by 2s. So this might be 8, and this edge might be 10. So this box is somewhere, out in the middle of the graph paper somewhere, and we need this box because we need to actually plot a point that is horizontally 9.2 and vertically 13.7. And a math person might write that as an ordered pair, right? 9.2 comma 13.7, kind of our x value or y value for graphing. So this is 9.2, this is 13.7. And the question is, where exactly in this grid should that point be placed? Is it down here somewhere? Over here somewhere? Kind of over towards that corner? Where in this grid should we put this dot so it most accurately represents, the numbers that we're trying to plot, the 9.2, 13.7. All right, so this is the method that we use, and it's actually kind of the same method in both directions. I zoom in just a little bit here so we can maybe see the numbers a little better. Let's do the horizontal one first, and what we do is we find the values at the edges of the box that we need. 9.2 is between 8 and 10, so we need the box that is marked 8 on one edge and 10 on the other. And what we do is subtract those values to find the difference. 10 minus 8, which is 2. Right. Hopefully you can do that math in your head. Otherwise, you can always use a calculator. But yeah, hopefully that one you can do in your head anyhow. And since we have 5 boxes going across the bottom, what we do is we take that difference and divide by the number of boxes. So we take 2 divided by 5 and change that into a decimal, which is 0.4. Now, once again, hopefully you can do that one in your head, but if not, for this one you can use a calculator, absolutely. And you would put into 2 first, number on the top goes in first, divided by sign 5 equals, and we'll give you a decimal of 0.4. So what that means is we are now actually counting by 0.4, and we're adding 0.4 every time we go up one of these smaller boxes. So I'm just going to write these values in so we can kind of keep track of what they are. So the first little box is now 8.4, and then 8.8, and actually the next one is 9.2, which is the value we're trying to graph. We'll be back to that in a moment. And then 9.6. And if we add 0.4 into 9.6, we should get 10, which is at the edge of that box. Depending upon what numbers we're working with, this could be some sort of kind of long random decimal number. If possible, you want to probably, probably keep 2 sig figs. So as you add across, hopefully at the edge of this box, you should end up with exactly the value that we're expecting. Right? So if we had 9.6, if we have 9.6, add that 0.4, we will get the 10 that we were expecting at the edge of that box. Vertically, it's exactly the same process. We're using slightly different numbers, but it's the same process. We find the difference between the 2 edges of the box, which is 15 and 12. And we subtract to find the difference, which in this case is 3. Right? And just like horizontally, vertically we have 5 boxes going up and down. Most graph paper is symmetric. We have the same number of boxes going across that we have up and down. So we take 3 divided by 5 change that into a decimal. Once again, use the calculator if you have to, and we get 0.6. So our y scale, or our vertical scale, we are going to count by 0.6s going up the graph paper. So we have 12.6, 13.2, 13.8, 14.4, and if we add 0.6 onto that, we get 15, which we should. Right? 12.6, 13.2, 13.8, 14.4, and 15. So that's our y scale. Now, as you do more of these, you'll find out that these patterns do kind of keep repeating. I mean, every time we count by 2 in either direction, right, the small boxes will all be worth 0.4. That's always going to be our decimal we're going to count by. And if we count by 3 in either the y or the x, right, it's always going to be 0.6. So you'll become familiar with these numbers the more graphs that we do in class, right? And you'll know these numbers well enough, you might not even need to write them down. But for now, if you need to mark each one of these squares, right, you can go back to our original graph paper now, and across the bottom, wherever the 8 and the 10 are, you can actually now, put these numbers in if you need. But you only need to really need to do that in the boxes or the values where there is a point you're going to graph. If there's going to be a point somewhere vertically above this, you might want to write those numbers across the bottom here. But you won't need to write the bottoms values across the bottoms of these if there is no point that's going to appear above that somewhere. And if it gets too crowded at the bottom of the graph paper, you can always go up to the very top of the graph paper, and put your values across there. Or, for the vertical ones, once again, it's on this side of the graph paper where we'll be writing our numbers on the big boxes. If you want to transfer to the other side, that is where you can put the values of the small boxes. By the way, my dog says hi. That's what that was all about. So, going back to our actual example now, the question is, where would I graph 9.2 and 13.7? Well, the 9.2 value is pretty easy to see. It's going to be right along this line. Now, 13.7 is between 13.2 and 13.8, but it's fairly close to 13.8. So my best estimate for the place to put that dot would be right there. That would really be pretty, so that should be our point. And that is how we find kind of the smaller scale inside of the big scale for our boxes when we're creating a graph. Now, as I said, there is a pattern to this, and what you'll notice after we do a few of these is you really only need to find out this pattern once inside of one set of boxes because the pattern will repeat. Let's pretend this box is actually just to the right of our original one. So if we slide this all the way over, it would actually be right in beside it here. Now, what would the values on that be? So we're counting by 2's, right? So that would be the 10, that would be this edge, and then this one would be 12. What we'd find is if we still count by our 0.4's, our first box's little x value for the little box here would be 10.4, and then 10.8, 11.2, 11.6, and then 12. And now if we kind of go back to our original box we did, this one was 8.4, this is 10.4. 8.8 compared to 10.8. The first box ended with a 0.4, the next box ended with a 0.8, our next box ends at a 0.2, our last one ends at a 0.6. And the difference from one box to the next, if we take 10.4 and subtract 8.4, we get 2. 10.8 minus 8.8 is 2. 11.2 minus 9.2 is 2. And you might not be surprised that 11.6 minus 9.6 is 2. And that 2 comes from our original scale. So not only does each of the big boxes count up from one box to the next, each small box to the corresponding next box inside of the next big box is still going to scale up by 2. So once you find the pattern for one of these boxes, it's going to be the same pattern repeating for the next box and the next box and so on. And the same thing happens vertically. Right? Vertically, if this box was actually right underneath that box, right, we're counting by 3's, this edge would be 9, this would be 12, and looking back up, we counted by 0.6's vertically. This is 9.6, and then we have 10.2, 10.8, 11.4. Right, and comparing these numbers, these are all 3 different because we're counting by 3's, right? 9.6, 12.6, 10.2, 13.2, and so on. So once again, you'll find out once you get used to doing these small divisions and small scales, the patterns will become more apparent, and the more of these you do, the easier it will become. This is absolutely one of those things in science that practice will absolutely make progress. Thanks for watching.